Recurve Bow Equipment Tuning. Introduction to tuning competitive Olympic recurve bows. Hi, this is Shihan HU, your archery coach and director of HU Archery Mission, as well as the director of the Coaches Committee, Archery Association of India. You are in the Level 1 Archery Coaches Workshop of the HU Archery Mission and the Archery Association of Tamil Nadu, TAAT. In this section, you will learn about the introduction to tuning competitive recurve bows known as the Olympic bow. In this session, you will know about 1. The importance of shooting technique before tuning a bow. Next, installation of accessories or assembling the bow. Then you will learn about the type of various risers available for the bows. And then you will learn about forces acting on arrows. And finally, the FOC or front of center balance. There is no doubt that the bow you choose is an important consideration. But even more important than the bow are the arrows you choose. In the early days of competitive archery, it was not uncommon for an archer to pay a month's whole income of his salary to buy a dozen of quality arrows. Remember, it is not the bow scoring the points in the target. It is your arrow shafts. Successful bow tuning and accurate shooting can only be achieved by using arrow shafts that are properly spined to your bow and ones that are consistent in their spine, weight and straightness. Follow the many available spine charts or computer programs on your market to select the arrow size recommended for your draw length and bow poundage. Remember to read all the information provided on the proper use of the chart too. The true verification you have selected the correct spine will be determined only during the tuning process. Problems caused by improperly spined arrow shafts will become evident during your tuning process. Before tuning, be sure that all your arrows are straight, properly fleshed and have perfectly aligned nocks. First, let's talk about why shooting technique is important before you start your tuning process for the recurve bows. Your shooting technique can have a large influence over the dynamic spine value of your arrow. How you shoot is very, very important. Two archers shooting the exact same bow, same poundage and the same arrow length may not necessarily shoot the same arrow size. Usually the archer who has a better line, a proper line, proper form will shoot a lighter or a weaker spined arrow than an archer who has a poor skeletal alignment and a bad form. This is because the archer with good alignment creates a less side movement of the string on release, resulting in less column loading of the arrow shaft. Next, installation of all accessories or assembling the bow. Before starting the bow tuning process, be sure to install every piece of equipment on your bow that you intend to use during your shooting. This includes the correct bowstring and all attachments to the bowstring, bow sight, stabilizers, arrow rest, cushion plunger, counterweights, etc. Choose all personal items as well, like your finger tabs, your chest guard, chest protector, and anything else you will need when you are shooting. For example, simply changing a stabilizer can have an enormous effect on the tune of your bow. Any adjustments made to the bow or changes in bow components can and usually will affect the tuning. Once the equipment is fully assembled, the next phase in the process of achieving well-tuned equipment is good preliminary setup, setting up the bow. If the initial setup is done properly, the tuning process can be accomplished with little effort. By following the bow setup guidelines in the initial preparation of the equipment, you can eliminate most or all of the possible tuning problems that can make the process time-consuming and probably unsuccessful. Adjustments made to the bow, changes in bow components, or alterations in shooting form can affect the tune of your equipment. Everything affects the tuning of your equipment. Remember, you and your equipment share a unique relationship and are totally integrated. Any change to either will produce varying results. During the tuning process, it is vitally important that you change only one variable at a time. Otherwise, it's very, very difficult to determine what adjustment caused any grouping changes. If after trying all the tuning adjustments outlined in this session, if your arrows still do not fly true, it may be necessary to change your arrow size to a stiffer or a weaker shaft and then retune. Arrows in flight spin, vibrate and oscillate in the horizontal plane and oscillate in the vertical plane with a misplaced knocking point. Proper bow setup and tuning will help minimize the forces on the arrow and help the archer to achieve optimum performance. Unfortunately, there are many theories on arrow flight, and vigorous mathematical treatment of these is a bit hard for most non-engineers to understand. The bottom line though is that all archers can recognize the arrow flight problems and make appropriate corrections. Check the drawing shown normally in the rotation of arrows in the horizontal and vertical planes. When I come down to the practical classes, I'll draw it for you. In this section on recurve bow tuning, it will be necessary to discuss a number of different types of risers since the available adjustment features differ in each case. Now the various types of risers are: one is a simple wooden self or takedown bow, the ordinary bow. Then you have the metal risers with cushion plungers but no weight adjustment capabilities. You cannot change the weight of the bow. Metal risers with cushion plungers and weight adjustments but no limb pocket adjustment capability. And then you have this sophisticated Olympic recurve risers with weight adjustable cushion plunger and limb alignment capabilities. Forces acting on the arrow. What are the forces that act on an arrow? For the purpose of simplicity, all discussions from this point on will be made in reference to a right-handed archer shooting at a right-handed bow. If the archer is shooting a left-handed bow, the same comments apply but in the reverse. As the archer releases the arrow, the string moves horizontally to the left, facing the target, moving the nock to the left. As the string starts to move forward, moving the nock end of the arrow, the point end resists the move, and this results in the arrow bending forward towards the bow. When the arrow completes this initial bend, the string and nock move back towards center and then to the right of the center. At this moment, the front section of the arrow pushes against the sight window face or the cushion plunger if fitted. All of this action occurs in a fraction of a second in the first several inches of the forward travel of the arrow. In the next horizontal bending sequence, as the arrow leaves the bow face and the arrow rests, the arrow is in a nearly free mode, only being held by the bowstring during the second half cycle. At this end of this complete cycle, bending in forward and then bending away from the bow, the arrow nock disengages from the bowstring, sending the arrow on the way to the target. These actions of the arrow are termed Archer's paradox and are the cause of the arrow vibration and arrow horizontal oscillation. You need to know the position of the fingers at full draw at the time of the release of the path of the string, and then you'll understand the initial bending of the arrow as the string propels it towards the target. Now we will next deal about the FOC, or the front of center balance. FOC is very simple to understand. Arrows fly more accurately and with more stability if they are front heavy. This is particularly true of shooting in the wind. The term used to describe the location of the arrow's balance point is FOC. It is defined as how far the balance point is forward of the arrow midpoint and is expressed as a percentage of total arrow length. FOC is equal to L below 2, L below 2 minus B, L into 100, where L is arrow length, B is length from balance point to the front of the arrow. For outdoor shooting, many archers assemble their arrows with quite a high front of center balance point, though this depends on the type of arrows being assembled, the length of the arrow, and the poundage speed of the bow. Consideration must be given for acquiring a good sight mark at the longest distance being shot. For indoor shooting, a high front of center balance point may be used, but be aware that going too high may be detrimental to the performance required. Well, so much for this session. In this session, let us revise. We discussed, number one, the importance of shooting technique before you tune a bow. Number two, we discussed about installation of accessories or assembling the bow. Number three, we discussed about type of risers. Number four, we discussed about forces acting on the arrows. And finally, we discussed about the FOC, or front of center balance. Catch you soon with the next part of recurve bow tuning. Let's break up here. Since the lecture is loaded with information, it will not probably get into our heads easily. If it does, then you must be a genius. Please listen to the lecture over and over again in your headphones. This will truly help you understand what I have been telling you. Keep repeating till you are thorough with it. I will be explaining every part of this lecture in simple detail in several sessions all through the year and in the practical classes with many more lectures till you have completely grasped it. God bless you. Catch you soon. Bye-bye. This is Hu.